So in this video, we are going to be doing some algebra required for foundations of physics. So we're just going to be rearranging equations and making sure that we know how to rearrange equations. It's very often we are given the task of finding the value of a variable in an equation that needs to be rearranged. So we have this equation here, which is Coulomb's law, and let's imagine that we have all the information except for r, which is the distance. So in order to find an expression for r, to solve for r, we need to isolate it on its own. Now, first thing that I want to do is I want to get rid of this k here. What I do is I divide both sides by k, and what I notice is that this k and this k cancel. So now I'm left with force on k equals q1 q2 over r squared. Now, because the variable that I want, r, is in the denominator of the fraction, what I would do now is I will flip both fractions. In other words, I would do force on k to the power of -1 equals q1 q2 over r squared to the power of -1. You notice that since I'm doing power of -1 to both sides, I'm not actually changing the equation. Everything is still the same, and I'm allowed to do this. Now, the reason why I'm doing power of -1 is because of the following index rule, where if I've got a to the -1, this is equal to 1 on a. So you can think of a as being equal to a over 1. So every number is a fraction just over 1, but we just don't write it because it's not necessary. And then if you do a to the -1, that will flip it. So we can just... So now this is going to be equivalent to k over f is equal to r squared over q1 q2. Now, I want to get rid of the q1 and q2 here. So I'm going to times both sides by q1 q2 times q1 q2. And what I notice is that this cancels with this. And now I'm left with k q1 q2 over f is equal to r squared. Now, I need to now get rid of this square here. And what I need to know is that to get rid of a square, I would need to apply the square root. The reason why the square root cancels the square is because the square root is the exact same as to the power of 1/2, right? So it's just a notation thing. The reason why we write this is just notation. It's the exact same thing as having something to the power of a half. And because of index rules, this is going to be equal to x to the 2 times 1/2, which is going to be x to the 1, which is just x. So what I will now do is I'll get the square root on both sides. So k q1 q2 over f is equal to the square root of r squared. And then we can now say that this r squared cancels this square root. Therefore, we have found that r is equal to square root k q1 q2 on f. Now, because this is just a number times a fraction, I can just, another way of writing this is k q1 q2 over f. So this is us staying consistent with the fact that k isn't a part of the fraction. Well, it is, but it's just not in the numerator. It's just times and still. It's the same thing, right? Now, should there be two expressions for r? Justify your answer. So what we need to know is that when we take a square root of any number, say if we have the equation, x squared is equal to 4, and we want to know what value for x satisfies this equation, right? Well, I will take the square root on both sides, equals square root on 4, and I get that x is equal to 2, right? But what if x is equal to minus 2? Well, minus 2 squared is equal to minus 2 times minus 2, which is equal to 4. So when we take the square root, we need to actually do a plus minus square root of 4, because there will be a positive answer and a negative answer, because squaring is just timesing that whatever it is that I have by itself, and if the thing that I have is a negative times a negative will always be positive, so there's always two answers with squares and square roots. Now, because we took the square root in this step here, should there be r equals plus or minus k q1 q2 on f? And the answer is no, because r is a measure of distance, because you see here, so distance, r is your distance. R is a measure of distance, so it doesn't make sense to have a negative distance. Thus, we neglect the negative answer and accept positive only. Okay. So given that the frequency of a wave is given by this equation here, speed over wavelength, where we have wavelength given by the Greek letter lambda. So this is lambda. It's just a Greek letter. What is an expression for the wavelength in the following equation? So we have that E is equal to h times f, but we have f is equal to this. So this is equal to h times v on lambda, and we want to find an expression for the wavelength. So what that means is we have to isolate a lambda. We'll need lambda equals something. So this is equal to E. So E is equal to h v on lambda. We're going to do what I did before with the k. I'm going to divide both sides by h. So this is h, and then this cancels with this. So then I'm left with E over h is equal to v on lambda. And then again, I'm going to flip both of the fractions here. Now I don't actually need to write the the brackets minus 1, because it's just not really necessary. So I can just flip them like this. As long as I do it to both sides, it's okay. And now I can times both sides by b. And then I notice that this will cancel here. And now I have hv on E is equal to lambda. So this is the form that we want. Okay. Now, if E is equal to W naught plus EK, find an expression for the velocity which depends on W naught and EK. So we would need to just say that E is equal to W naught plus EK, which is going to be equal to this guy here. But this guy is equal to this guy. So I'm just going to write equals to h v on lambda. Now I need to find an expression for the velocity, so this is v. Okay, so we have w naught plus ek divided by h is equal to v on lambda. And what I've done again is I've just divided both sides by h. Sorry. And the h's cancel. So here I don't need to flip the fractions because I have rv in the numerator. So I can just times both sides by lambda, and that will cancel with that, leaving us with lambda w naught plus ek over h is equal to v. Now another way I can write this is lambda w naught plus ek with brackets around it because it's timesing it by everything, or I can distribute it like this, and then I would get something like w naught lambda plus ek lambda. It doesn't really matter as long as you don't write it incorrectly. Now solve for n. So first I will do what we've been doing in the previous questions, and I will just get rid of this 7, 8, 40 on both sides. So that will cancel with this, and now I'm left with 1/2 n is equal to 490 and 7, 8, 40. So then I will do calculator 490, 7, 8, 40. So 490 on 7, 7, 7, 8, 40 gives 0.0625, but I want my answer as a fraction. So what can I do? What can I do? Let's do this. So 497, 40. 497, 840. So 1 on 16. So now what I can do is I can use the distributive law of an exponent, and notice that this n will go into both powers, or it will be a power for both of the numerator and the denominator. So then I have 1n on 2 to the n is equal to 1 on 16. And I know that 1 to the n will always be 1, so 1 times 1 times dot 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 times 1 n times will always equal 1. So I can get rid of the n here, I don't need it. And I also know that 16 is equal to 2 times 2 times 2, so 2, 4. 4 times 2 is 8, so times 2. So this is equal to 2 to the 4. So now that I have an expression like this, I can see directly that n here will have to be 4. So n equals 4. Now next question. Given the equation q equals mc delta t, so this triangle is another Greek letter, delta, and I want to rearrange it for m. So I can just write this mc delta t, and to get an m on its own, since m is timesing itself with this whole thing, I can just divide both sides by c delta t. And I notice that this will cancel all of that. Therefore, m is equal to q on c delta t. Now I want to solve for b. So here, first I'm going to times both sides by 2 to get rid of this 1/2. So if I times by 2, times by 2, this will cancel with this, and then I'm then left with 2ek is equal to mb squared, and then I'm going to divide both sides by m, cancel, cancel, b squared is equal to 2ek on m. And now, because we have a power of 2, we need to take the square root on both sides. So b squared square root is equal to square root of this whole guy over m, and this cancels with this. Now, should there be two expressions for this variable? So should I have something like this, or would I have something like this, so plus or minus? And the answer is we should have the plus or minus because our velocity is a vector quantity, meaning that the negative velocity has meaning, right? The negative tells you which direction you're going. So if we denote positive velocity to be right, so normally it's going to be going right is the positive direction. Then if you have a negative velocity, then that means that you're going in the opposite direction, right? So if phi of b is equal to ab cos of theta, what is an expression for b? So this is another Greek letter, so this is just phi. And this is an equation for the magnetic flux. So an expression for b, what I would need to do is I want to get b on its own. Since b is just timesing itself with a cos of theta, I can divide both sides by a cos theta, and I see that this will cancel with this. Therefore, b is equal to phi of b over a cosine of theta. Now, if cos of theta equals y is equivalent to theta equals the inverse cosine of y, well, what is an expression for theta alone? So I want something like theta equals dot dot dot. Now, what I would need to do is I would need to first get rid of this AB here. So I have AB cos of theta is equal to phi of b. This is the same as cos of theta equals phi of b over AB. And that works because I'm just dividing both sides by AB. Cancel, cancel. Now, by using this equality here, this relationship, I can say that theta will be the inverse cosine of this whole expression here. So therefore, theta is equal to the inverse cosine of phi of b over AB. So that's our answer. In the expression, t equals 2 pi square root of m on k, what happens to the period t if I double the mass m? So I have initially 2 pi m on k. What happens if I go from m to 2m? What happens to t? Well, let's see. Let's just put it in the equation. Let's just put in 2m into the equation. So then I have t nu is equal to 2 pi square root of 2m on k. And what I can do is I can write this as 2 pi times, so this is just going to be square root of 2 times square root of m on the square root of k. Now, the reason why I can do this is because of the index rule here. If I've got something like this to the n, this is equal to a n, b n, c n. The n will just distribute. But in this case, we have n equals 1/2. So this is exactly the same as 2m on k to the 1/2, right? And since all of these terms are multiplied by each other by the property of associativity of a multiplication, I can move it around. So I can say that t nu is equal to square root of 2 multiplied by 2 pi square root m k. So therefore, what I notice is that this is t here. So therefore, t of nu is equal to the square root of 2 times t. So it scales slash increases by a factor of square root of 2.